Hi guys. I was searching around for cool math topics as you do, and essentially chose which one to present based on how much I cringed. Weird repeating decimals ended up on the top of my list, so I'm rolling with it. First of all, zero point 0.9 repeating does not mean 0.9, or 0.99, or 0.999, followed by a finite number of nines. 0.9 repeating goes on forever, never ending. Don't object to 0.9 repeating equals 1 on the basis of however far you go out it doesn't equal 1, because there is no however far to go out. You can always go further. Don't agree? Argue with me. Geometric series style. As we know, 0.9 repeating equals 9 tenths plus 9 100ths plus 9 1,000ths, etc., which is equal to 9 tenths plus 9 tenths times 1 tenth plus 9 tenths times 1 100th, etc., which is equal to 9 tenths plus 9 tenths times 1 tenth to the first plus 9 tenths times 1 tenth squared plus 9 tenths plus 1 tenth to the third, etc. Now we can see that this is a geometric series with first term a equals 9 tenths and common ratio r equals 1 tenth. Since r is less than 1, we can use the infinite sum formula to find the value. 0.9 repeating is equal to 9 tenths times 1 divided by 1 minus 1 tenth, which is equal to 9 tenths times 1 over 9 tenths. Is equal to 9 tenths times 10 ninths, which equals 1. So 0.9 repeating equals 1. Ha! You're a feisty type. Let me set a precedent. Since you're so smart, you probably know that 0.3 repeating equals 1/3. And 1/3 plus 1/3 plus 1/3 equals 1. So 0.3 repeating plus 0.3 repeating plus 0.3 repeating, which is 3 times 0.3 repeating, should equal 1. But 0.3 repeating times 3 equals 0.9 repeating. So 0.9 repeating must equal 1. Still skeptical, are you? How about some simple algebra instead? The expression 0.9 repeating has a value. We'll call it x. Multiply this equation by 10, and we'll subtract these equations. Get x equals 1. So 0.9 repeating equals 1. Surely there's no doubt now, but you argue. Shouldn't there be a 0 at the end when you multiply by 10? Yeah, you're completely right. If there was a finite number of nines, but there isn't, it's infinite. It's repeating forever, it doesn't terminate. So there's no end to put the 0 on. Checkmate. Okay, English. Some say that while 0.9 repeating gets arbitrarily close to 1, it's never actually equal to 1. But what does arbitrarily close mean? The number doesn't move. It just sits there, looking at you. But the sequence 0.9, 0.99, 0.999, and etc. does get arbitrarily close to 1. For each term, the difference between that term and 1 gets smaller and smaller. There is no smallest difference. It can always get smaller. This getting arbitrarily close refers to something called limits. And according to limit theory, getting arbitrarily close means that 0.9 repeating does indeed equal 1. I prove this in English. There is no dispute. So I win, right? You were an argument? Ah. Well, I hope you learned something anyway. Thank you so much, and I hope to see